Okay, well, people who are joining this live stream, this is going to be a quick meeting, I certainly hope, talking about a variety of things for version 12. Let's see. Okay. General approach to the description of uncertain numbers. Where are we using that description?
Yes, so the best thing is to review the page of around, the ref page. And my point there is that there are different ways of approaching the description of what around means. And I'm trying to be there explicitly ambiguous so that we don't constrain ourselves to...
I wouldn't call it mu then. I would call it x and dx.
I started like that, but then in around replace, we have the replacements of variables by arounds. So then it's natural to say x goes to...
Well, why don't you say x0 goes to? Why don't you say x, I mean, something like, I see, x1 goes to, that's not a reason to not do it here. Well, why don't you say, x1 tilde dx1 or something. Something like that here. Or the left-hand side could be, what could we do there? I mean, you talk about...
Yes, so there is a description in terms of statistics, but the main definition box, the wording is explicitly ambiguous.
For which? For this up here?
Yes, uncertain numbers, rather than going and talk about random variates and...
Oh, I agree.
Yeah.
I wouldn't say with value that. I mean, I would say what about first of all, I strongly think it should be x and dx. And I strongly think it should be minus and plus for L and R.
Do you mean the subscripts?
Yes.
Okay. Yeah.
Okay, so I'm proposing then that this become, if I can, let's see whether this will work. I don't know what this is doing here.
I can change it later.
Yeah, okay. Well, I just want to see what it looks like. Okay, represents well, I think we want to use the word around here. Represents a number whose value is around x with uncertainty dx. How does that strike you?
Good. I'm still thinking about the dx. The x is fine. The dx, perhaps u could be another possibility.
Or delta?
Delta would be better, yes. A single letter would be better to avoid confusion of products and things like that.
I'm not worried about the product part of it. I kind of like dx because it allows us to say dx1, dx2, and otherwise we got to, otherwise we'll have delta. Is it delta 1, delta 2, those kinds of things. Let's try this. Okay, so the case we have to, okay, so represents a number around x with asymmetric uncertainty with maybe we can say here, to make it, which I think will make it even clearer, something like that represents. Do you think that's useful?
Well, it seems a bit circular in the sense that our representation of that is around.
Yeah, fair enough. Okay, fair enough. You're right. But we do need to say, is that really right, though, this claim here? I mean, it's not really quite right that that's what.
Why not?
Well, because we're not really doing transformations on normal distributions. It's only an approximation to that.
Yes, but the approximation isn't the transformation itself. Once we have a round, we are assuming the Gaussian distribution. Then when we do an around replace, then we do the approximation.
No, but I mean, when you say around something, look, if I say sine of around, pi over 2, comma, pi over 2, comma 0.4, for example.
Mm-hmm. Yeah.
Wow.
That's a case that, yes, the linear approximation is very bad, right?
Right, but that's a linear approximation. So
yes, but the problem is not in the around, but in the sign. It's during the sign computation that we
I know that, but I think what we should say in around, look, represents a value number with value around x and uncertainty dx. Represents an approximate number, an uncertain number, an approximate number. Okay, so here I think we need to say, if we say here dx, I don't know whether I'm going to get this right, minus dx, very bad idea. Help dx underscore plus represents a number with value around x and asymmetric uncertainties. By the way, does this have numbers with errors in it? Yes, thank you, good. You can do this. I'm going to mess this up.
Yep.
How about dx plus?
So for example, the dx minus. So you think it's clear that the minus refers to the whole dx, not just the x?
I think so. I mean, you could get confused, but I don't think I think the idea of x plus or minus dx is a reasonable concept here. Okay, but let's can we use to represent measurement results with uncertainties and other numeric values? Okay, let's say, let's see, around is displayed in standard form How do we write that out? As x plus minus dx, where that character is what? If I say around...
We have template boxes. We don't have a character. So
I see. So you can't enter it with a character there.
Not at the moment. In the future, we will have an escape sequence that creates the template box for you.
I think that's a useful first comment to make here. Okay, so now I think we should be saying something about what this thing... Oh my gosh, we're out of time. This is terrible because we got to discuss around replace here. I think we should say around is combined yeah, this is important as well. That's a very important statement. Okay. When around numbers are combined using blah blah blah, right? And what about this kurtosis, the third argument and the correlation functions and all that kind of stuff? Oh, that's in vector around.
No. It's here, but I was planning not to expose this for the moment.
Because
very few people use it and the computations get quite slow. So I'm hoping to be able to improve the speed of all of this.
I think it's still useful to show people that it's possible. It helps them understand what this is.
That's okay.
Okay, so wait a second. So let's say around can be used in numerical computations. Is it only numerical?
Well, what do you mean?
Well, I want to say something about how around is combined, automatically combined in a numerical operation and so on.
I see. Well, it's basically calling around replace to do that. And then the description of how that works is in around replace. I think you have the page open.
Okay.
So there is where there is the fundamental formula, which of course it's very generalized to the case of multivariate and etc. But that's the fundamental step.
Now, what are you proposing in terms of a rename for around replace?
Yes. So the idea is that now that we have separated vector around from around, and vector around represents basically multi-normal distribution, then sometimes around replace is going to return a vector around from something that was not a vector around originally. So I have the impression that if we follow the precedent of transform distribution and call this around transform, it's going to feel nicer and more gentle.
Excuse me. But this is it has very much the look of a replace.
Yes, it does. But if we think of the arrows as the wiggle in of distributed, it's also the same thing. It does feel like a replace. But for example, if you start with a list of objects, a vector in the first argument, and you get a vector around back, would that feel...
Well, okay, so you're saying if I say around replace, and then I say x squared, x cubed.
Right.
Right? And then I say x arrow around 2 plus or minus 1.
Yeah, so right now this returns that because it's threading. But I want it to return a vector around because there are correlations among those numbers. So transform distribution does that. Transform distribution, it takes a list of random variates and returns a multi distribution. I think we should follow that as well.
So, okay, but if I were to get here, if I were to say vector around, and how does it, what are the arguments to vector around? Ooh,
it's a vector, and then either the list of sigmas if they are uncorrelated, or the covariance matrix if they are correlated. right? And then a matrix there, for example, or yes, the sigmas. So that's a vector arrow.
Why doesn't it typeset in a reasonable way?
Because there is no standard typeset for this.
But why not? Why not have 248 plus minus 142, 1412?
Because if we could do that for the vector, but if we have a covariance matrix, we cannot say vector plus minus a matrix.
Yeah, right. Okay, so now how do I resolve this?
This type of thing has to go through a round replace. When there are correlations.
Okay, but how do I get rid of the correlations? How do I say forget the correlations?
I haven't prepared any way for right now. Perhaps if, I don't know, we could say a round of this guy and get a list of rounds.
That might make sense, yeah. A round, a vector around.
Yeah.
Yeah, I mean, there's no way that a round replace can give the right answer without using some kind of correlated vector around type mechanism.
Exactly, yes. Somehow the fact that now we have separated around for vector around exposes a lot more the flexibility of vector around, or the capabilities of vector around.
Why did we do? I mean, okay, fair enough. Okay, very practical point. I'm clearly we're not going to be able to. Oh, wait a minute. What happened here? This meeting got extended. My schedule got all moved around here. Well, that's good. We have got another half hour in this meeting.
Oh, yes, I see that.
Good. Okay. All right.
Yeah.
So
the vector case, I'm currently extending it. So the scalar case is settled.
Okay. So let's start represents an approximate number with value around x and uncertainty dx. I think that's okay. By the way, do we have a guide page about this stuff or not yet?
Not yet. That was the last point in the agenda. I think because we have only 4 functions, perhaps the best thing to do is to put it in one of the scientific.
Well, yeah, but we should have a page specifically about uncertainty. Okay, look, you know what? I want to make such a page. Okay. Oh gosh, why is that $M version not working there? Okay, so numbers with uncertainty or something?
Uncertainty in measurements. My worry is not to confuse people into thinking that we are going to have here all about precision, set precision, etc.
Okay. I think it's still okay. And that's going to be, all right, so now, okay, so what we're going to put in here, this will be, so I mean, the basic point is the Wolfram language, numbers with uncertainty as obtained, for example, from measurements.
Yes. Perhaps you can say numbers and quantities.
Okay, so here, okay, Well, so that's a number, right? So the quantity, the quantity is around the around, so to speak.
It can be inside or outside, yes.
Something like that.
Mm-hmm.
Okay. So now we want to talk about vector around, presumably.
Yeah. Yes, these are the two containers.
Vector of correlated numbers with uncertainty, right?
Yes.
Okay, so now we also want to show quantity and probably quantity array as well, right?
Yes, quantity array can have internally around objects.
Okay.
Individual around objects. Eventually, we should have an around array.
Okay, so maybe we should just want to say well, let's see. We want to say quantities with units. Maybe that wants to be okay. Let's just mock up what else we have to talk about here. We have to talk about around replace and mean around, right? That mean around is important. And then we also need to start talking about list plot, et cetera, right?
Yeah.
And that has various options.
Right, the error bar, yeah. Mm-hmm.
Plot lists of uncertain list of numbers with uncertainty, lists of plot lists with uncertainty indicated by error bars, etc. What are the options for list plot that determine that?
I think they are called error bars and error bar function. Let me check.
Okay, so
yeah, error bar function and error bar style.
Okay. Oh yes, somebody is asking on our live stream. I got to show this because it's cool. Okay, so let's say table around n random real 2, for example. Okay. Ta-da! Isn't that cool? Mm-hmm. So which other functions support this?
Functions that support error bars.
Well, no, list plot. So we've got also okay. So hold on. We've got what were those things called? Sorry, error.
Yes, the options were error bar.
And this is going to have to be knitted into visualization as well. But keep going. Error bar what?
Sorry, no, it's wrong. It's interval markers and interval markers style. Sorry, I got an older version. interval markers style.
Okay, well, we'll need to look at that in a minute. Okay, so here, vector of correlated numbers with uncertainty. All right, so now we want to say, how do you go from a number with a distribution to an around thing? So if I say a round of normal distribution, what do I get? Do I get what I think I will get? Oh, that's interesting. That's a bug in a round, by the way. Right?
You mean the caret?
Yeah, the caret.
Yeah.
Now, what happens if I put in here something other than a normal distribution? Let's say I have a log normal distribution.
It's going to call mean and standard deviation.
Okay, that's cool. All right. Okay, fine. So let's say generating numbers with uncertainty. And here we want to say mean around.
Mm-hmm.
And then we want to say normal distribution. But now, if I say normal distribution of and around, what do I get?
No, that is not going to work. Because
why? I think it should work.
No, because the first argument of normal distribution is the mean. So we would be describing the mean with an uncertainty.
Are you sure we shouldn't hack this to make it work? I mean, how do you get out the distribution that corresponds to the normal distribution if you are claiming that the normal distribution...
If you want, we can add one of these properties. So because around is going to be a flexible object, for example, we may want to get back a number with a precision that corresponds to its error.
Yes, quite.
So for those type of things, I'm preparing properties. So we can have an around blah, 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 and then a property called distribution or normal distribution.
Okay, all right, fine. So, but let's document this then. So, okay, generate a number, find the mean and uncertainty of a list of numbers, including the uncertain. Well, find the mean. Let's see. How should we say this? Find. What does it say in the actual documentation of mean around? I see. Get the mean and uncertainty. A list of numbers together with its uncertainty. It's a little weird.
There is an important point here, which is there in an excluded cell in mean around, which is that when you have a distribution of numbers, this is not going to this returns the mean and the uncertainty of the mean.
Yes.
The uncertainty of the original distribution that generated the numbers.
I understand. So I assume that you can do mean around of around numbers, and that will do the right thing.
Yes, it's going to take the uncertainties.
Yeah. Okay. I see it
use
here.
them as weights. Yeah.
Okay. All right. That's good. Okay. So here we'll want to say represents an approximate number
Yeah, because it's going to compute, I would use returns or gives.
Okay. Gives an approximate number around the mean of the distribution, dist with an uncertainty corresponding to its standard deviation. Is that right?
Correct, yes.
Okay, now the other case that we've got here, which I don't know how we usually do this, is to indicate the properties, right? Is it going to be a table down below?
Yes, I think so, yeah.
Okay. Can be used in numerical, wait a minute, can you, when around is used, when around is used in numerical computations, uncertainties are combined using, well, assuming that they are uncorrelated, well, using a linear approximation, assuming no correlations. Is that even vaguely correct?
Yes, it is correct. Because the only way of adding correlations is either via vector around or via around replace.
Okay. By default, combined using a linear, but is it right to say using a linear approximation?
It is.
Well, using a first order approximation.
Yes, that would be better. Yes, it is some sort of first order Taylor approximation, but I mean, you can say first order.
But how about computed using a first order Taylor approximation, series approximation? Why is it Taylor? Is it Taylor or series?
Well, to me, they are the same thing. I would use either. Either of those. Series approximation.
Okay. How about propagated, like you've used here?
Yes, that's a standard or traditional term.
Okay. Okay, now, okay, so the following properties around ... prop can be used to extract the following properties. Is that reasonable?
Yep.
Okay, so then first one of those is so first one will be value.
Yep.
So we want to say central value. X in around X comma dx. Uncertainty. So what is that if it's asymmetric?
It returns the pair.
Okay. Uncertainty dx in around X dx. Okay, now what's the next thing we've got here?
Yes, it's able to compute, for example, we have something called approximate number, which will return a number with precision corresponding to that. And interval as well.
Okay, so hold on. Are we really going to call it approximate number? Or, yeah, I guess so. Number with value X and precision.
If you want, you can say directly accuracy dx, or accuracy, well, it's a logarithm, but it's accuracy given by dx.
Actually, corresponding to dx.
Yes.
Okay, so next case we have is
interval.
basically that, right?
Exactly.
Okay. I think we should also say distribution, which gives the normal distribution.
Right.
So that's basically x dx, right?
Right.
Now, if it was skew, if it was dx minus dx plus, then it's
Then I think either we return some sort of
mixture distribution of some kind, I would think. I don't know. What is that distribution?
yes. So Roger has something for this. It's a distribution that has 50% on one side, 50% on the other side, even if they are not continuous.
I see. Oh, it's a name distribution.
Yeah.
Or distribution, Rogers distribution, whatever it is for dx minus dx plus.
Right.
Okay. All right. What's this? Finite precision numbers, intervals, and strings. What the heck is a string doing there?
Yes. So this is something quite useful, because imagine that you have numbers in a paper which have zeros on the right, because people want to control significant digits. So you can say a round of a string 1.200, and then
Okay.
you know which.
Okay. We need to document these things. Okay. Okay. So the first thing here is a round of, I don't know what we should call it. I'm kind of thinking x with a tilde on top or something. Boy, I use that way of getting these tildes once in a blue moon. Gives well. So this is let me understand the case. So the first case, okay. So first case is an interval, right?
Yes, but I'm not sure these are important enough to deserve their own lines.
Well, fair enough. Then let's combine them all in one line. Okay.
Right. So it's kind of a converter from other representations.
Yes. Okay. Well, fine. Then let's go ahead and make it a separate line here. Oops. All right. Round of, what do we want to say? X spec or something of spec. Gives an approximate number derived from the specification spec. Derived from the well, we got to say something about what that specification is.
Yes, so this can be a number, an interval, string, a distribution.
Well, we already said the distribution above.
Oh, okay, so you want to keep that one, yeah.
Number, interval, or string specification spec. All right, so then what we have to do, okay, so then probably what we want to say here, in, around, well, here, maybe it goes below this. So then the next steps here, we've got to say something about how the things are displayed after this. As with uncertainty, can be specified as follows. Okay, so the cases are, we've got a single number here.
Yes, a number with finite precision, and we will extract the precision as meaning.
Okay. A number with finite precision, approximate number with finite precision.
Yep.
An approximate number whose precision, whose accuracy,
it's accuracy, exactly, because it's absolute.
whose accuracy is used to determine uncertainty, whose accuracy corresponds to the uncertainty.
Yep.
Okay. What's the next case here?
An interval. It's the inverse of what you have above.
Okay. So this is an x min. Definitely not the right thing there. What did I just do? Okay. Well, let's see. Actually, here, maybe we should just say approximate number. And then we can say over here, what is the formula?
It would be a round of x, comma, 10 to minus accuracy of x.
Okay. And this one is a round of x mean of x min.
Right.
I can't type this properly, and I'm not going to. Okay, mean of that, comma, and then it's x max minus x min over 2, isn't it?
Yes.
Oh, gosh.
I can fix that.
Okay, you'll fix this.
Mm-hmm.
Okay, so now what's next here?
Then we have a string.
Well, we also have a distribution. Let's give the distribution case here.
Okay.
Oops, that's not what I meant. I meant, well, it's a distribution.
Yeah, it's any one.
Round of mean of distribution, comma, standard deviation of distribution.
Right.
Okay, then what?
String.
Okay, what does that do?
It's a string containing a number. I don't know how to represent that. Perhaps we can have a number inside the string, inside quotes. And then it's going to, this will be something like to expression, but then there is not a well-defined formula for the uncertainty. It's something like uncertainty 1 on the last significant digit.
Okay. Uncertainty, okay.
Something like unit uncertainty in the last significant digit. Perhaps you can say n dot xxx or something like that.
Here?
Yeah, to represent
Number string. Okay, well, let's say nn.xxx.
Yep.
Our system for picking up incomplete ref pages is going to trigger on that xxx.
Perhaps we can use these, like decimals, ddd.
That's a hack. All right, okay. Number string. Okay. So this is a round of two expression ...
And then 10 to minus the number of these.
with uncertainty with the last digit with uncertainty given by the last digit.
With
the
uncertainty
last
determined by number of significant digits. By number of significant decimals or digits.
No, I think it's digits, not decimals, right?
Well, it depends. We shouldn't count the n's. We have to count the d's, let's say.
I see.
Would it be too weird to subscript the D's and then have a handle on the last, on K or something?
That's really weird, I think. All right, okay. So let's keep going here. So on the guide page, all right, so okay, so how do we get out? Okay, first of all, okay. Such numbers built-in capabilities for computing and visualizing with numbers. Handling, let's just say handling. Okay, we want to talk about the fact that it computes and visualizes and oh, it's okay, I think. Okay. All right, so now do we want to talk about number form or any of the other number display things? How does number form work with all of this?
This has its own typesetting, so it's not affected by number form. So the idea is to have in the future a round form, which will be able to modify this.
Okay. Let's see. Whose value, quantity with units whose value can include uncertainty. Is that fair?
Yes, perhaps you mean whose magnitude?
Okay. Okay, so now we need to put in somewhere here.
Yes, we need uncertainty propagation.
Right, but here we want to talk about distribution specify a distribution to approximate with numbers with uncertainty, by numbers with uncertainty. Is that reasonable?
Well, I'm not sure the sense of approximation here, because it's going to strictly take the mean and standard deviation.
I know of that, but once it's...
Yes, but then it wouldn't be a normal distribution, it would be any distribution.
Okay, well, fair enough. Well, okay, use a distribution to specify numbers with uncertainty. I don't know if that's quite right, because that suggests, I mean, I'm trying to give the idea that there's a connection between these things.
Yeah. Perhaps you can say normal distribution, comma, ...
Okay, yeah, fair enough. Okay, all right, so then we also need to give a number with precision, right? Or an interval, actually. By the way, we should remember there's probably a guide page that talks about intervals that we should include for where we should include all these interval markers and so on. Okay, we're out of time here. Let's go back to the around replace, which I really do think is the right name. So we probably just need to say here, well, really that's a different situation, because that's symbolic handling of uncertainty or something. Is that right, or is that a stupid way to say it?
Well, it's not necessarily symbolic, because it can involve all numeric rounds. I would call it just uncertainty propagation, a new section together with generating. And then we have there.
Okay, so then what do you propose to say about it? Replace symbolic variables by uncertain numbers counting for correlations.
I think the key idea here is that of starting with a function of these random variates and propagate.
Okay.
So it's something like
replace variables in a function.
Yeah.
Well, actually, this is sufficient. Replace variables by uncertain numbers accounting for correlations, I think, is okay.
Yeah.
Okay. All right. Okay, we're not finished here, so we're going to have to go on. Maybe this evening would work. I was going to be away, but I'm not going to be. Would that work for you, perhaps?
Yeah, it works for me.
Okay. We might even do a live stream then, if we can arrange that.
I mean, is there any question related to list plot, given that we have Brett with us here?
Oh gosh, well, I would imagine interval markers and so on might be a question. What things other than list plots support all this stuff?
Very closely related things like date list plot, list log plot, and then bar chart.
Okay, well let's put those at least in the list here. Okay, list log plot. Does list line plot support it?
Mm-hmm.
List log plot. Okay, date list plot. And bar chart. Is bar chart interesting in its support of these things?
It will draw error bars.
Yeah,
well, so will all of them.
Yeah.
Well, yes, but I mean, like, pie chart will accept a round, but it's not going to draw anything relevant to it.
I see. Okay, interval markers. So what we want to say here is option to specify how error bar intervals should be rendered, should be plotted. And what's the difference between that and markers style?
The style controls the coloring and thickness and that sort of thing.
Coloring, thickness, etc. of error bars. Is that right?
Yep.
Okay. Now, do you want to say anything else about other visualization functions? Other things don't yet support this, correct?
Correct.
I mean, other things will just ignore around. That'll be true, right? If I give
A lot of things will. I mean, like plot will probably doesn't know to ignore it yet. I need to double check that.
Okay.
Okay.
So we have a few questions on our live stream. I just want to address those before we wrap here. Question was about random real of a round. Oh, that's interesting. Random real. I bet we didn't support that. Did we support that? No, we didn't.
Not yet.
Okay, good suggestion.
Mm-hmm.
I mean, should we random vary it, right? Or
well, probably both should work.
Yeah, probably. I mean, I think random real can technically take a distribution in its first argument.
Can it? I don't know. Let's try it.
Because I think it's, we didn't have random variate originally.
Yes. Okay. So random real and random variate should support around. Good suggestion. Can I add to approximate around numbers each with a different distribution? No, that is the slippery slope down which we cannot go. The fact is, okay, I can say this will work beautifully. I can do any kind of operation. If I do something like this to the power around, 2,0.1, it'll be magnificent. It'll work perfectly, but it's using a first order approximation. So if I were to give different distributions here, it will work, but only in a first order approximation. Yeah, if you want to actually combine, what we should do here is we should say, we should have a section under numbers with uncertainty that talks about exact handling of distributions. And then we should have just a pointer to things like transform distribution and so on.
Right.
What are the things we should point to?
I would say mean, standard deviation, transform distribution, and covariance. Mean, standard deviation, covariance, and transform distribution.
Sorry, covariance you're saying next?
Covariance and then transform distribution.
Okay, question. Does this work if I take that around number and I say mean of %13? Does that work?
No, not now.
Should it? I think it should.
Well, again, this is a slippery slope of forcing around to be propagated throughout all of us.
Yeah, I know.
I think
which eventually will happen. But the question is whether that would be a useful thing to have immediately. Seems like it would be useful.
Well, mean of a list of arounds treats them as individual numbers. So having one is kind of a different interpretation.
I see.
So we have to think a bit about that.
Okay. All right. We should wrap for right now. And we will try to, I'll get the schedule for later. I'll push these back. Thanks to folks on the live stream. We will be announcing the later live stream later. Okay. See you all soon.
Bye.
Bye.